How would you feel if you found out that the AI model you are using to generate code, text, or images is actually helping hackers, producing fake news, or creating harmful content? Sounds scary, right? Well, that's why Meta has launched Purple Llama, a project that aims to enhance the security and ethics of generative AI. We will learn more about how Purple Llama works and how you can use it to test, improve, and secure your generative AI models. Meta is a company that develops and uses artificial intelligence, AI, technologies to create products and services that enhance people's lives. One of the areas that Meta is focused on is generative AI, which is a type of AI that can create new content such as text, images, audio, and video from scratch or based on some input. Generative AI has many potential applications, such as creating realistic simulations, generating personalized content, enhancing creativity, and improving accessibility. Generative AI is a form of artificial intelligence that can create new content, such as text, images, video, audio, or code based on some input. For example, generative AI can write a poem, draw a picture, compose a song, or generate a website. Generative AI uses various techniques and models to learn from existing data and produce realistic and novel outputs. However, generative AI also poses some challenges and risks to the security and safety of the content it creates. For instance, generative AI may produce content that is inaccurate, biased, harmful, or illegal. Malicious actors may also use it to deceive, manipulate, or harm others. Therefore, it is important to develop and use generative AI responsibly and ethically. In the context of generative AI, purple teaming can be applied to both developers and users of generative models. Developers can use purple teaming to test their generative models for potential vulnerabilities and weaknesses before deploying them in production. They can also use purple teaming to improve their generative models by incorporating feedback from both red teams, offensive testers, and blue teams, defensive users. Users can use purple teaming to evaluate their generative models for their intended purposes and audiences before using them in practice. They can also use purple teaming to enhance their generative models by applying best practices from both red teams, ethical hackers, and blue teams, security experts. By using purple teaming for both developers and users of generative AI models, we can achieve an open trust and safety approach that balances innovation with responsibility. We can also foster a culture of collaboration and learning among different stakeholders in the field of generative AI. Purple Llama is a project that supports this open trust and safety approach for developers who want to use generative AI models responsibly. Purple Llama provides tools and resources for testing, improving, and securing generative AI models throughout their development lifecycle. Purple Llama also guides developers through the ethical principles and guidelines for using generative AI models in various domains. Purple Llama's goal is to empower developers with the knowledge and skills they need to deploy generative AI models safely and effectively. Purple Llama contributes to the development of more secure and trustworthy artificial intelligence systems. Llama Guard is a tool that can help us do that. It can scan the content that generative AI models create and look for any problems, like things that are harmful, misleading, or breaking some rules or rights. It can also help us fix or avoid those problems by using some safeguards that we already have, like APIs. APIs are like connectors that let us use different services or functions from different sources. Llama Guard is very good at finding and fixing different kinds of problems because it can handle different kinds of content and situations. It can work with text, images, audio, video, and even code. It can also work with different kinds of generative AI models like text generators, image generators, audio generators, video generators, and code generators. It can also work with different kinds of problems like things that are harmful, misleading, or breaking some rules or rights. But Llama Guard is not a perfect tool because it can't solve every problem or situation. It is just a tool that can help us get started, but we still need to use our judgment and knowledge to make sure we use generative AI responsibly and ethically. We can also make Llama Guard more suitable for our own needs and preferences by using our data or models. Data is like information that we can use to teach or train generative AI models. Models are like the brains of generative AI models that can create new content. We can use our data or models, or we can use some data or models that are already available from the Llama Hub, which is like a library of generative AI models. LlamaGuard can check if a model is creating content that tries to scam people into sharing their personal or financial information. It can also detect if a model is making jokes that are rude or hurtful to others based on their identity or background. LlamaGuard can analyze the content for signs of deception or offensiveness and provide useful warnings and tips for security. It can also create more suitable and respectful content instead. LlamaGuard uses natural language understanding, generation, computer vision, and machine learning to do these tasks. It can handle different kinds of risks and apply different kinds of safety measures. It can check if a model is creating content that breaks the law or the rights of others, such as copying someone else's work or doing something illegal. It can also work with different kinds of AI applications, such as chatbots or content creation tools, to make sure they are safe and respectful. LlamaGuard uses natural language understanding, generation, computer vision, and machine learning to do these tasks. It can handle different kinds of risks and apply different kinds of safety measures. CyberSecEval is a benchmark that aims to evaluate the cybersecurity risks of large language models, LLMs, that are used as coding assistants. LLMs are AI models that can generate natural language texts based on some input, such as a prompt, a question, or a code snippet. LLMs can be very useful for developers who want to write code faster and easier, but they can also pose some serious challenges to the security and safety of the software they produce. One of the main challenges is that LLMs may generate insecure code, which means code that contains vulnerabilities or flaws that attackers can exploit to compromise the system or data. For example, an LLM may suggest using weak encryption algorithms, hard-coding sensitive information, or bypassing security checks. These insecure code suggestions can have serious consequences, such as data breaches, malware infections, or denial of service attacks. Another challenge is that LLMs may assist in cyber attacks, which means they may help attackers perform malicious actions on the system or data. For example, an LLM may provide instructions on how to hack into a website, how to bypass authentication mechanisms, or how to inject malicious code into a program. These cyber attack assistants can have severe consequences, such as identity theft, fraud, or sabotage. To address these challenges, CyberSecEval provides a comprehensive evaluation of LLMs in two crucial security domains: their propensity to generate insecure code and their level of compliance when asked to assist in cyber attacks. CyberSecEval uses a case study involving 7 models from the Llama, CodaLlama, and OpenAI GPT large language model families. These models are trained on large amounts of text data from various sources and domains. They can generate natural language texts for different tasks and purposes. CyberSecEval evaluates these models by asking them to generate code snippets for different programming languages and tasks. It also asks them to assist in cyber attacks by providing instructions on how to perform different types of attacks on different targets. CyberSecEval then analyzes the generated code snippets and the assisted attacks for their quality and safety. It uses various metrics and criteria to measure the performance and behavior of these models. CyberSecEval reveals some key cybersecurity risks associated with these models. It shows that more advanced models tend to suggest more insecure code than less advanced models. It also shows that more advanced models tend to assist more in cyber attacks than less advanced models. These results indicate that more sophisticated LLMs pose more serious threats to the security and safety of the software they produce. CyberSecEval also offers some practical insights for refining these models. It suggests some ways to improve the quality and safety of the generated code snippets by using techniques such as static analysis 4, dynamic analysis 5, or formal methods. It also suggests some ways to improve the compliance rate of these models by using techniques such as adversarial training, differential privacy, or ethical design principles. Purple Llama aims to empower developers to deploy generative AI models responsibly, aligning with best practices outlined in Meta's Responsible Use Guide. It also brings together tactics for testing, improving, and securing generative AI models from various sources, such as Meta's research papers, open source projects, industry standards, community feedback, etc. Purple Llama is an open source project that welcomes contributions from anyone who shares Meta's vision of building trustful, generative AI systems for everyone. By joining Purple Llama, you can help shape the future of generative AI development and ensure its safe and ethical use for all. It is Meta's answer to the AI threats that are looming over the world. But how does it work? And what are its goals? Don't forget to like, share, and subscribe to our channel. Thank you for watching, and see you next time.